You are watching a lab video that will recreate a crude oil spill in a marine environment. By introducing OilFlux BTI cleaner, you can see how quickly crude oil is recuperated, without adversely impacting the site. The lab technician has filled a glass tray with water to simulate a marine ecosystem. Crude oil is then poured over the water's surface to generate a spot with an extension of 15 centimeters. The technician fills a spray bottle of BTI solution and applies over the crude oil spill area. The extension of the crude oil spill vastly shrinks in size in reaction to the BTI chemical. In the event that a crude oil spill possesses a low API, the reduction of the spot will not be as dramatic. However, it still maintains its ability to extract the crude oil from the surface of the water without impregnating equipment that is being used in the crude oil recovery operation. Here, we will simulate crude oil recovery in one type of ground soil. The lab technician pours a sample of crude oil into the beaker and also stains the beaker's walls to illustrate the effectiveness of this cleaning product. The lab technician pours sand into the beaker. The sand and crude oil is mixed so that the entire mass is uniformly homogenized and impregnated, as well as the walls of the beaker. Since the beaker has a capacity of 800 milliliters, the lab technician proceeds to pour 40 milliliters of BTI and fill it with warm water. The emulsion formed is agitated at 500 RPM for about 20 minutes. It can be observed that the impregnation of the crude oil on the beaker walls is diluting into the emulsion until it disappears completely. At the same time, we see that the sand is already moving freely in the emulsion because the crude oil has detached and emulsified with the clean water. The stirrer is removed and left to stand for 5 minutes. If left resting longer, you could see how the emulsion changes color, leaving the lower part lighter and the upper part darker. This occurs because the crude oil rises to the surface. The liquid surface is completely covered by the crude oil that detached and separated from the remaining liquid, allowing to extract it from the liquid mass for its later recovery. We can see that the beaker's walls are clean and free of the crude oil. The lab technician pours water, and the liquid that overflows is decanted in another beaker, making sure that the crude oil residue doesn't impregnate the sand. The sand is placed in a mesh with a pore size that permits holding it. We can see that all of the crude oil that impregnated the sand has detached, and once again the sand is clean, just as it was before the demonstration started.